Welcome to Code Chix. I'm Karen Rehmeyer. Emily's another Code Chix founder with us. Naveen is going to be our presenter today, and Alex from Madison College is going to videotape for us and put it up on YouTube. We have a YouTube channel. Our goal is to get all of our talks up there. I'm a little bit behind on that. So I'll tell you about Code Chix. This time we're three groups together. We're Code Chix, which is its own organization, got started about 6 years ago in California, got started in July here in Wisconsin. I also made a Code Chix meetup because a lot of Madison people find each other through meetup, and all it does is feed to these events. And then there's a Women in Tech meetup that they are also advertising this event. So we might get a few more people, but Code Chix. They say that 50% of women software engineers drop out within the first 10 years of being in the industry. We hope to make that number lower by helping women software engineers stay in the field. There are people that say that in the next 6 years that we're going to have 1 million more jobs than we have people eligible to fill them. So I think IT is a neat field to be in. At the rate that we are graduating computer science majors, and with how widespread the IT jobs are, there's a huge need here. So we'd love to have people join us. We're dedicated to the education, advocacy, and mentorship of female engineers. We have, at this point in Madison, we just have tech talks. So we've had 2 already. We had one in August, how a feature is born from concept to implementation. We had one in September, testing beyond JUnit. And this is our 3rd one, Spring MVC. Our 4th one is going to be in January with Naveen again on Spring Boot. In the works, I think we may get a Madison College student who has already been accepted to work at Apple and created an Apple game that you can get on the Apple Store. She may come speak to us. So from the UW, one of the computer science professors, some of her TAs created a way to test all the exams. They now work at Google in town, and they have agreed to come speak to us. And somebody else in security has said that they may come and speak to us. So I've got a bunch lined up. I'm aiming for about every 2 months with tech talks. If we have a huge amount of interest, we may move up to workshops that are hands-on a couple of hours. And if there's a huge interest and people want to get together and hack, you can. So we're trying to be face-to-face women software developers, keeping current, meeting each other, supporting each other. That's what this is about. In the Bay Area, they started about 6 years ago. They had all these different kind of workshops, and I read about them and said, well, I want to go to those. So I guess I will make that. So, like I said, we started in July. There's our website. Go there. If I'm able, there will always be an event on there. So I've got the next one ready. I just have to say go live. I hope to link that better back so you can see the past events and you can see the slides and the videos for it, but that's not quite done yet. Our mission is local women developers, helping local women developers, particularly those early in the career track, and those of us further along that can help the other ones keep coming. That's what we do. I just told you about that. You can find it on the website. We'll take anybody. If you are more advanced, lead a talk. If you are less advanced, don't be intimidated. What we need is people to come to these events. We need people to speak at them and to tell each other about Code Chix. Nationally, there's a bunch of sponsors. And locally, we've got some. Madison College is giving us the rooms anytime, anywhere. So, and offering to videotape for us. That's great. There's a website. You can email me, and that's it. Any questions? Okay.
Welcome to Spring and Spring MVC. So I'm going to start, before I start, how many of you have worked with Java? All right, so pretty much everybody. Have you worked with any kind of
We just mocked up an hour.
Oh, okay. So this requires a little bit of Java experience, but I hope you can pick things up. Has anybody worked with Spring at all? Okay, so a couple people have worked with Spring. Okay, so for you guys, some of this might be a repetition of stuff, so I am really going back to the basics. So this is geared towards people who have not worked with Spring at all, know, and worked with Java but not with Spring. So that's what this talk is geared to. My name's Naveen VK. I've been working with Java since 1997. That's when I first started working with Java. It was like 0.8 or something like that. So we've come a long ways from there. A little bit about myself. I'm a principal architect at NVIZIA. NVIZIA is a small company of consultants. So we go out to other clients and basically do a lot of custom development and integration, whatever you guys need. I've got, like I said, 15 years of industry-wide experience, full cycle development. I've done a lot of front-end web apps, some back-end apps, like a handful of those, but a lot of those are front web apps and a little bit of like batch processing and things like that, but primarily front-end apps. Like I said, I've got 17 years of experience working with Java and Java-related technologies and frameworks. Something interesting about myself. Let's see. I'm a black belt in karate. I'll name three things. I ride a motorcycle. My uncle taught me how to ride it when I was 16, so I've been riding it for a really long time. And third thing about myself, I love to run. I do a lot of half marathons around town, so if you're a runner, you'll probably see me running. The Arb is my favorite place to run. So that's something a little bit about myself. And I was born to be a geek. My dad's an electrical engineer, so that's how I got into geeky electrical stuff. I can still change my own, I can swap out sockets and things like that. I'm not afraid to touch any of those things. Daddy's girl. So here's the agenda for today. So we'll look at what is Spring, and then what is MVC, and then we look at what is Spring MVC. So at a very high level, this is what we'll be looking at. Right? So before Spring, so let me do a demo of what this before Spring things look like. Right? This is before Spring framework was there, and this is how we did it old school. And I have written apps without Spring, so let me get into. So I'm using the my IDE. The is Spring Source Tool Suite. It's based on Eclipse, so it's pretty much like Eclipse, but it has a lot of Spring stuff in it, so that I don't have to download all those jars and things like that. But for this, I did go download the latest bit of jars and stuff for Spring. I think the latest version that I've worked on is 4.03. I'm not sure if there's something later than that out there. There's probably 4.1 something, but that's the latest version I've worked on. So here is old school. Right, so we have our, so what I'm demoing is a to-do app, right? So you have your task list, you know, you add tasks, delete tasks, so keeping it at a very high level and not keeping track of like all the various funky things that you can do with that. So very high level. You have your tasks, you know, a to-do list, and then all you do is add or delete. Once you're done, you just delete it out of your list, and if you have a new task, you just add it to that. So I need my bean, right? So my bean or my business object for those of us who work in the industry, I have only one right now. It's task. And my task has just two things, an ID and a description. An ID is just a random incremental integer that I'm using. A description is pretty much what the task is all about. Can everybody see this? Is the font too tiny? Okay, good. So this is my plain old, as we call it, Pojo's Java bean. It's a Java, plain old Java bean with just two properties and the getters and the setters for that. And I have a two-string method just so I can see what's printed out and stuff like that. So old school was, so we had our beans, and then we had services that took care of, that did things with our beans, right? So, which is why I have this task service. So let me maximize that so you guys can take a peek at it. So the task service took care of everything. So I have this bean, right now, like, it's all in memory. So that's why I have this list of tasks, right? Here's my list of tasks. And then I'm keeping track of what my max ID is, so a new task gets added, I just implement that. So this is what it is. But in the real world, that probably is persisted somewhere in some database, somehow, and that, the service will take care of all that stuff. So this is just a demo of what this service is. So I can add a tasks, all the things that I can do with my service. I can query my tasks and figure out what is my list of tasks that I have to get done, and I can delete a task. I also have a couple of other methods. One is a get task by an ID. It's pretty straightforward, so it just iterates through my list, and then if something matches the ID, it returns that. If nothing matches that ID, it returns null, right? So that's all it is. And then I have a task given a description, figuring out, you can get to a task using the ID or the description. So basically that's my task service. And this is what my task client would look like, right? This is something that, so we have services, so we have beans, we have services, and we have clients. And so this is what my client is gonna do with that. So it's just an old Java application, another plain old, Java bean called, and it creates a new instance of the task service, adds whatever tasks I want, prints out all the tasks, and then deletes tasks, and then prints out all the remaining tasks. So to see that run, I'm gonna just right click and say run as a Java application. Right. So on the console, this is why I have the two strings, so I can print out what my tasks are. So initially I had 4 tasks: finish my code, finish my presentation, do the demo, and then go home, right? So I finished my code, I'm yet to finish my presentation, and I'm doing the demo right now. So I deleted as you can, if you remember what my task client did, was it deleted that go home task, right? So it got that task using the description and deleted that task, because the delete task method, just, you need to give it an ID to delete it. So this was really, really old school. To make things a little better, so the thing with the problem with this is your task client is connected to your task service, right? So if your task service changes, but your task client doesn't, there's problems, right? If I change anything in my task service, right? If I change anything in my task service, I might break things in my task client, right? So let's say I get rid of the get task by ID. I'm just gonna comment that part out. And when you're creating these services, you have no idea what clients are using it. And if I don't know, if I check this in and create a new component out of this and send it to somebody else who's using the service, I might be breaking that code because I've changed that task service. Because there's a hard connection between the two. In my task client, there's actually a hard import right here. I need that specific task service. And without that, my code won't work. So in order to get around that, we started using interfaces, right? So your interface is your contract between the service provider and the client. And so beforehand, we agree that these are the services I'm going to provide, irrespective of how I implement it in the background, right? And this is what my client can expect to see will be implemented. So this task service has an add task, a get task by a description, add task given a description, delete task given an ID, and get the list of tasks. That's it. And here's my implementation. Right, so here's my task service implementing the task service. Instead of an array list, I'm using a hash map of string and task. String is the description and the task is the task object associated with that. You know, I'm just showing you that there's so many different ways to implement your service. You know, my first one, the simple one, just had an array list. This one is a hash map. And this is what it does. So add a new task, increments the max ID, creates the task object, and puts that in my map. Same thing with the get tasks, right? So given a description, the description is the key, that's my map. I just get whatever is associated with that. And delete is, I just go through everything in there, and if there's a task that matches that ID, I just remove it from my map, and that's it. And get the tasks. So even though my service interface said I need to return a list of tasks, and in my implementation, I have a map, so that's how I grab the values from the map and convert it into an array list and send that back. So that's how we did that old school. The thing with this is, so the way we implemented what implementation, so these are Java patterns, that standard patterns that are out there. So what implementation gets used where is by this task factory. The task factory is where the hard coding happens, right? And so I can, behind the scenes, swap out my task service info with something else completely, a totally different implementation. My client will still work. Nothing will break the client, because as long as the client is concerned, as long as I implement those 3 or 4 methods in that interface, it doesn't matter what my implementation does, what else my implementation does. And so this was a better way to handle. I'm looking for a word, tight coupling. So loose coupling. This was one of the ways to loose couple things. But once again, here, the task factory was charged with the job of making sure it knew what specific implementation to use. Right? So if you did not have the right implementation there, things may break. And my client, so this is the client to the interface, I asked the task factory. So I asked the factory, give me this service. And the task factory will, whatever implementation it's using, I can swap things behind the scenes, but whatever implementation it's using right at that point will give you the implementation of that service, right? The actual object. And then I can do all the stuff that I normally did. Same thing, it's very similar. Create the tasks, print out all those tasks, delete a task. It's very, very similar to the other one, right? It's very, very similar to this one. The only difference here is, here, there was a very tight coupling between my client and my actual service implementation. Here, using interfaces, I was able to abstract that out. And so it's a looser coupling of that. Running this one. Same thing. Let me undo this thing. Okay, questions so far before we go ahead? Right, so initially it was all concrete classes, tight coupling. Then we started using interfaces. That was a lot more looser coupling, and life was a little better. Still not that good, but a little better. Before I jump into Spring, there's a couple concepts that that you guys need to know. One is called the inversion of control. So as you can see that in the examples that I showed, the client controlled what implementations we used, right? And my factory, if I had it at the client level versus the service level, right, the provider level, then I'm tight coupling things again, right? So inversion of control is flipping that whole thing around. So this concept is where you take a generic reusable library or framework, and that is what controls the flow in your code, right? So way back when we first started, it was your custom code that controlled the flow of your program. Now here we have a framework or something else that's controlling that. So that's the inversion of control. So it's not your custom code, but it's something else on top, that sits on top that controls how that flow is going to happen. The other concept that you guys need to know is called dependency injection. So this is nothing but an implementation of your inversion of control, right? So here, a dependency, which is our service, is injected into a dependent, which is our client. And you'll see how Spring does that. So two concepts, inversion of control, where the flow of the code and what calls into what is not down at the custom level, it's more at a higher level. And dependency injection is how that gets implemented. You know, you're injecting your dependency between your service and your client at runtime, pretty much. That's pretty much what's happening. Any questions about these two concepts? Okay. All right. So now we start looking at that Spring framework. So Spring was probably, so prior to all this stuff, I used to code homegrown specific stuff which did things like that. I created factories, all that stuff. And I meaning us developers, had to code all those things, right? And if things were, you know, the whole transactionality, like what happens within a transaction, within a database, all that stuff, you had to code all that stuff. And if somewhere you messed up, then it was big production issues, figure things out, work late nights, and fix those things before the users come in tomorrow. Still happens, but at least Spring takes care of some of those things. So Spring is an open source framework. It provides support for the configuration, for dependency injection, for transactions, so it does so much more than just dependency injection and version control, right? AOP is aspect-oriented programming. That is basically, it's a concept where if there's some cross-cutting concern, like logging, like security, you take that out as a totally separate thing, and that is what AOP is. So you do have, Spring provides support for all that stuff. Data access, integration, web application, web services, there's batch, there's so much more that Spring offers. We're just looking at like the first little, dipping our little toes into Spring to see what is, at a very basic level, what it does. But it offers so much more. It's, the one that I'm looking at is for the Java Enterprise Edition platform. There is Spring.net for the .NET stuff. I've never delved into that. So what I'm focusing on is Spring for Java, and that's pretty much it. There's a whole bunch of modules that are grouped into, so it's basically, all these things come as modules, and you have to figure out what modules you need for your app to run. And so you have all these modules are nothing but different jars, right? So everything in Java is packaged as a jar, and that becomes your module or your component. And so with Spring, you have all these things grouped into a whole bunch of modules. One other thing about Spring, there's the concept of bean. Everything is a bean, right? Just like my task service is a bean, my client is a bean, my task object, that class, that is a bean, everything is a bean. The other thing about Spring Beans, they have scope. By default, everything is a singleton. A singleton means that in the JVM, there's only one instance of that. There's only one object of that class, right? So if I talk about task service, there's only one task service throughout the entire JVM. So if I ask Spring for my task service, it's going to give me a reference to that one object. That's the only one that exists. There's a way to change that. By default, everything is a singleton, right? So we look at some of the configuration and things like that. By default, everything is a singleton, but you can specify, you can enhance the scope. You can specify the scope to be, one is a prototype, and that is basically every time you ask for it, it creates a whole new object of whatever you're asking for and gives it to you. The other one is you can have session scope, you can have request scope, right? Your HTTP request scope, your session scope, and then you have other, I think the custom application, thank you, application of, yeah. So most of the time, the Spring Beans that you declare will be your services, your data access, those things. You do not declare your actual like task as a Spring Bean at all. You'll use that, but your Spring Beans are mostly the services, pretty much. And with Spring MVC, we look at what else can your Spring Bean be. So that's where what you're configuring. So any questions here? So here is, I borrowed that from the Spring Framework website, and these are all the modules that you have, right? You have your core container, your Spring Beans, your Spring Core, your Spring Concept, really haven't used that. That's your core container.
Spring expression language.
Thank you. Yes, I knew that was something like that. There's your database stuff, whether it's JDBC, JMS, your data access, not just database, it's your data access, right? JMS is your messaging service. JDBC, just JDBC ORM transactions. There's your web stuff. Our MVC will come from those modules. Then you have all these other AOP and aspects and messaging and instrumentation, and then test. We will look at test as well. So I don't know what the last.
JUnit, testing beyond JUnit.
Testing
So
beyond.
she talked about JUnit mostly.
Oh, okay. So we look at JUnits, but using Spring. So this is from the Spring website, but those are the modules, and they keep adding to it. That's the basic one, but there's so much more out there right now.
Can Spring be used for mobile?
Yes, there is a mobile version of that, I think. I have not dabbled with it. All right, demo. So we've seen, right, so we went from our very simple task service, tight coupling, to slightly loose coupling using interfaces. Here is the whole thing with Spring. So what I did was, I created a class called Spring Task Service Info, just because I just extended the task service info because here's my interface. I'm still using the task service interface, so we do code everything through interfaces.
That's a typo, right? Spring? Sprint.
Oh, oops, that's a typo. Spring task service info was what I meant to say, not sprint. Sprints, scrums, that's a totally different thing. Sprint does mean something, though. So, how do I tell Spring that this is my service? We use what is known as annotations. And the @service annotation. So, way back when Spring was first implemented, we had to write all that configuration in XML. And every time something changed, had to keep that XML, in sync with the code. Really, especially if you have a big, huge code base, we always ran into class not found, bean not found exceptions, or bean instantiation exceptions because your constructor changed. So happy that they got rid of that and using annotations these days. So, sorry, go ahead.
Does that replace struts config XML and tiles-XML? I'm more used to struts,
Oh, yeah.
but that's what you mean, right?
Yep, but Spring used to have its own XML. So it's application context as XML.
Does it still?
It does. You can still use that. It's backward compatible. So if you have one, you can upgrade your Spring to the latest version and it'll still work just fine because it's still there. But you don't have to write new code that way. Yep, it'll work if it's all configured, yes, and it does work very well with struts. There's hooks to that. So the way to declare a service in Spring is @service. That annotation, and that's just a name. So every bean has a name, and that name has to be unique. I cannot create a task service info 2 and call it the same name. You won't catch it when you're coding, but when you're trying to run the application, it'll say, boom, I can't have 2 beans with the same ID. The ID has to be unique. So your application won't even start because that's the first thing that it loads. It loads up all these services. Task service, @service. I don't really have, since I'm extending that just to illustrate this, so I don't have to write all that code. So this is my configuration. You have to tell it what version of Spring that you're using. Since I'm just using beans and context, those are the 2 things that I have to grab, right? I have to tell it what version of each I'm using. And if I want everything to be auto-wired and I do a component scan. So my application XML simply becomes this one line of code. I give it my base package name, and I say, scan all the components, hook everything up for me. Boom, it'll do it. Other annotations are at entity. Those are your specific entities that you'll be persisting in the database. So if I was persisting my task in the database, I would annotate it with an at entity, right? Just like I did right here before the description of that class. At repo, at repository, that will tell me that this is my data access bean. This is what handles all my data. This is where all my queries are, if you're using straight JDBC, this is where all my insert, update, delete SQL is. And add services for the service layer. So generally, we like to layer things up. Is there a marker wrong here? So we layer things up. It's a good idea to not put everything in one spot, to layer things up. So you have your services, right? So that's your service layer. And whatever your client is that calls that service layer, that's your client. It could be that your UI is a client that calls into the service layer. So you want to have your separation of concerns. And your services will in turn call your data access, whether it's actually a database, whether it's a messaging, and that's how you separate those things out. And that is good programming, especially in the real world, just the separation of concerns, because some of that could be reused, right? So you could write a batch that use some of the stuff, maybe some services and stuff like that. So that's a good way to do it. And earlier, so I could declare, I won't save this, I'll just show you what a bean, so this is how, if I did, ID would be task service, class, this is where I'd hook up spring.sprint task service. This is how I would hook those up. So if I had all these services and everything, this is where I had to write it. So that was old school in Spring. But we no longer do that. It's all about annotations right now. Revert. Okay. How your client would call it, this is how the client would call it. It would say, here's my application context, right? It's in that Spring application context. I could create an application context just within that client itself. I want to get my bean, right? So that's my context. From my context, I want to get that bean, which is why it has to be a unique name, because that is our ID. And this task service is actually just my interface, right? It's my good old interface from back then. And then I'm going to do the same things. So on that guy, I will show you what so this is stuff from Spring that happens before. So it goes, loads up that application context, and then since that one I say, go scan that Spring package for anything that you can find. So that's your base package. So usually it'd be like com dot, abc dot, com/abc/ let's say project name, task web app, wire everything up appropriately. And so that's what Spring does. Questions? Wait, how are we doing for time? Okay. So now, since we got a little bit into what Spring is and what it does, for Spring MVC, that is your, if you have to write web apps, you need some kind of, if you don't want to write your homegrown code, you can still use the old HTTP servlet, you can extend that class, implement however you want, you know, your JSPs, your UI, you can do that. But then you have all these other frameworks that will help you with your web apps, creating your web pages and all that stuff. Struts is one of them, hooking your pages to the data behind that. And Spring MVC is the one that the last 5 years, that's what I've been using, Spring MVC. Except for one app where it was more of prototype, and that was all JavaScript based. It was all Angular JS with Ajax calls, nothing to do with Spring MVC. It's all a lot of single page applications, right? Like Google Gmail is a single page application. It's just one page. Everything is one page. And then depending on what you click on, it happens, you know, right? With the newer version, if you do a compose, that compose thing just, you know, behind the scenes, you can still see your emails. It's just one page application. So that's where the industry seems to be. They call SPAs single page applications. Okay. Sorry, tangent. Back to this one, MVC. So MVC is another design pattern. So with MVC, you have, basically stands for Model View Controller. Your model is your Java object, whatever your object is. In our case, it's our task, right? Our view is how I'm displaying that task. Right now, I was just doing system out print lines, so I can see that on my console. But if I convert it to an app, a web app, I need to have a page where all that stuff gets displayed. And then I have a controller which controls how data flows between the model and the view. So that is a design pattern. It's been there forever. And Spring MVC is basically a design, you know, that. Questions about MVC? It's pretty straightforward. You have your model, you have your view, your JSP, whatever your page controllers is the one that controls the stuff between the two. Spring MVC is an MVC framework from Spring for web applications, exclusively for web applications. Demo. It should be pretty. It was all on this one. If you noticed, the way I structured things, all my beans are under beans. Actually, if I show you my production level code, I have not interfaces, those would be my services. So if I have like a task service, that's what the services are. And I have both the interface and the implementation in the same package. And factories and other utilities that I need for that service, I just put it in one package. So let's say if you have account, then I have an account service. So I have account.bean, account.service, account.persistence, account.messaging. So I have everything related to account in one package, and the sub-packages define what it is. So that's how it's more, you know, that's what works for me. So and I've stuck with that for a long time, so I'm, that way. So here, I have what is known as this is my Java source, and all my web stuff is here, right? Web applications, has anybody worked on web applications? Okay, so a little quick thing about how things are structured for a web app. For a web app, you need your code that'll make your web application work, right? Otherwise, it's just static pages. But if you have to have, data and things for it to work, you need your code, and that's what your source is. Your actual pages, so this is using JSPs. That's my JSP, and then all that stuff comes under Webin. Your HTML, your JSPs, your JavaScripts, your style sheets, everything comes under that. Your web application is the configuration that tells your application server, wherever you're running your web app, all the things that it needs to run that application. So that's your configuration, so that's your web XML, and that's always under Webin, right? Your libraries are the libraries that are needed to run the application. So that's just basically the structure of that. So for Spring MVC, we said we need 3 things, right? I need a controller. So here's my controller. And since we're using annotations, I'm telling Spring that this is my controller by using that @controller annotation. And I'm also telling Spring what my methods are going to be mapped to depending on what I do in the web app, right? So in my URL, if I say, whatever my context root is, right? Like Google is mail.google.com or gmail.com or something like that. So basically, that's your context root, right? Apple is apple.com. That's your context root. So that's where all the Apple stuff is. So for a web app, you need something known as a context root. And then everything else after that, this is what it maps to. So if I do a welcome.do, this is what's going to happen. If I do a list, if I do an add, if I do a delete, those are the things that will happen. So basically what I'm telling Spring is, in my controller, if my URL says this, then come and execute this method, and then return whatever comes back from that. So annotations here are @controller, and the other annotation that we have is the @request mapping. I'm mapping my request, my HTTP URL request, right? And I'm saying this has to be an exclusive GET. So that's your HTTP GET parameter. And this is what it does. Same thing over here. This is also a GET because all I'm doing is listing my things to do. And my post is if I'm adding, deleting, those are the things. So if somebody accidentally does a GET on this, I'll show you what happens. It'll take care of that. And same thing with the delete is also post, right? So that's my controller. My JSP, I'm doing a single page application. Here is my to-do list. And here is my form, right? This is basic HTML. Here's my form. Here's my input type text. And here's my submit button. I'm just say add. And then for each item in the list, I list it out. And next to each item, I have another form for the delete, where I have a hidden attribute of the item itself. and then what needs to be deleted. Right? So that's pretty much what it is. So basic, and my index, I just added this just to illustrate something. You know, all I have is that to go to my to-do list, that's my welcome page. You can have your nice dashboard or whatever. By web XML, we'll have, this is my context root, calling it Spring MVC, sorry, this is my context root. Your servlet class needs to be that Spring Dispatcher servlet. And same thing for like my client, where I had to tell it where my application context is. I had to tell this where my application context is, right? That's for my web app. I have to tell it, in order to run this web application, grab my application context from here and wire everything up. And my Spring MVC, anything that says star.do has to be sent to my Spring MVC servlet. You could have, this is for when you have multiple servlets, and you could say certain requests go to this one, certain requests go to that one. This is how you do that. And then my welcome list is, you know, I have only one index.html. The other thing to show you guys is my application context. Very, very similar to what we saw earlier, right? I'm doing a component scan, and I'm saying that's my base package, grab everything from there. And I'm also telling, oh, here's the extra thing that I had to include. So earlier it was just context and beans, my earlier application context. Now for Spring MVC, I have to also tell it what my MVC is, what version of that I'm using. So I have beans, I have context, I have MVC. So by default, you always need beans and context. And depending on what else, you know, for a Spring MVC web app, you need Spring MVC, you just keep adding those jars or those components, modules. And I'm telling MVC that everything is annotation driven, so just go, there's no config. It will take a config. You can actually declare your controller here. So instead of scanning it, it'll go like, you know, just the way I did bean tag. You have a controller tag, a controller bean tag, controller tag. But it's so much easier to just do all this using annotations. Questions before I run the application? I can start the application and I'll show you what that, there it is. Happens really quickly. So it is loading up that configuration, right? Application XML. It's configuring all my URLs. /welcome.do, /todo, /list.do, right? All the things that I had specified. In this case, I had only one controller. If I had multiple controllers, it would configure them appropriately. And that's what it did. All that stuff for me, and it's saying my Spring MVC is done. That's what I was testing earlier. So, right? Refresh. There's my to-do list. Finish coding. Finish demo. Ask questions. Go home. Drink wine. Sleep. As I keep adding it, you can see that I added the this timestamp, so you see that it actually is working. It actually is refreshing everything. If I delete one of these, or I delete one of these, and keep it appropriately. I wanted to do an update one, which is why I have that disabled. So, but I didn't get around to doing that. Show demo. the one, couple things, let me make sure I've got everything here. So, the jar dependencies is what I was gonna talk about next. If you guys have any questions before that? Yes?
How are you building it? Ant or Maven or something else?
Oh, no. The thing, I would do some kind of build, a Maven build or something like that. But for this one, all I did was, actually, let me show you how I did that. So I stopped everything.
So when it scans the annotations, that's not really like compiling it, it's not really like building, it's another thing?
It is, but it happens at runtime. So it is, so what I did was, I have a Tomcat application server in my, so let me I'm gonna remove all, right? So Tomcat application server, lean. And start. So that's my application server. Right now, there's nothing running. So if I try to refresh this, right, this is my Tomcat saying, I have no idea what you're talking about. So this is an IDE, so it has an inbuilt one. So all I did was add my Spring MVC project to that. That's the project. So behind the scenes, it automatically built a war, deploy the war to the Tomcat server.
Then you don't need to worry how it goes.
Nope, not for testing. For production, I do. Right, this is my local, and this is what I do generally when I'm just testing my web app locally. I do have a Hudson server that does continuous builds. It handles both Ant and Maven.
So you don't do that at the application level?
Yeah.
Okay. You
Yeah.
can, oh, you do both in your shop?
Yeah.
Okay.
Yep. Yeah. So, so that's what, but locally, behind the scenes, it did war everything up. It did compile everything, it did war everything up and deployed it. But it just happens like magic. If you had a server running outside, you could do an export, right? Where's the war? Not jar. J2EE, I think. I would, web, sorry. I would export a war file. Destination, let me see. Temp, spring.war, right? Tomcat. So you don't have to install Tomcat. I did because I've used Tomcat for years now. So I prefer that to, it does come with its own, something that's Spring created. So you could use that. But I'm just so used to Tomcat that that's one of the first things that I do if I get a new laptop, install my IDE, my Tomcat, and kaboom, it's all ready to go. So let's see. It says restart. So now, add probably won't work. Yeah, well, let's see. Okay, good. Show demo was the last one I added, so it did do a test. Hello. So it did that behind the scenes. Okay, so one other thing that I wanted to mention was what are the things that you need. So let me go back to my basic Spring. Let me show you what my build path looks like. Right? So here are my libraries. I needed beans. I needed Spring context. These are the jars that I needed. I needed the context support. I needed core. I added expression even though I don't really need it. I did do a test, and let me show you how to run JUnits with that. I needed commons logging and AOP. So just to get my basic, right, things splitting out on the console running, those are the dependencies, jar dependencies that I had, right? I needed my Spring beans, my Spring context, my Spring core. I didn't really use expressions, so I didn't really use that, but those are the things that I needed. And if you did not have that in your class path and you try to run an application that needs Spring, it will throw a runtime exception saying, class not found or be not found or something like that. That was for my basic one. Before I go, let me show you, basically, this is my JUnit that I had, using annotations. Once again, I'm using Spring JUnit for class runner. It's the same configuration, so I'm just telling it, go find that thing in my class path, whatever my application context is. Go find it in my class path, configure everything, and this is how, remember in my client, I used the client assumed that it didn't really use Spring, but if I did use Spring even on the client side, this is how I would wire it. My service on my client side now becomes a resource. So I say at resource, so I'm telling Spring, this is my resource, and that's the name. Go find me whatever that thing is called by that name and hook it to this guy. And I'm telling it, this is my first test, and that's my delete test. As JUnit. So if I did not need JUnit, I don't need that Spring test jar. And I used it, that's why I created this test, JUnit test, that's why I needed that. But everything is using annotations. And I'll show you that. I'm just gonna call fail over here. Insert. Yep. Right. And if I rerun, it'll tell me that the delete task passed, my add task failed just because I added a field right there. So it is hooking everything up and running everything. So that's why I needed if you look at the reference libraries, that's why I needed the test jar. If I didn't use Spring's extension of testing with a hook into JUnit, I don't really need that. For my Spring MVC, here are my jars, right? Here's my AOP Alliance. Here's my commons logging. I need commons logging because by default Spring does a whole bunch of logging and it uses that, so I needed that. I was gonna do JSTL, but I never ended up doing that. Instead of using the form, the old HTML tags I was gonna do JSTL, but I didn't get around to do that. If I didn't need, that was why I had that, but I don't really need that just for this application. Here's my AOP, here's my beans, here's my context support for expression language, and I have two new things. I have web and MVC. Those are the two new jars that I needed for this one. So with Spring, you have your jar dependencies. You need those things. I have all the code uploaded into my GitHub account. I don't seem to have, it's right there. So there's my Spring MVC. That was a demo that I did last year for MadJug. Spring Data, that's a fun one. Maybe I could do that here. So I have not uploaded my PowerPoint presentation yet, and I will upload that in the same spot. There's my LinkedIn information. That's my work email, and that's my Gmail account. Any questions?
What's the difference between Add Resource and AutoWire? Does AutoWire just kind of know what type it is?
Yeah, I could have used AutoWire, then it would have worked. At Resource, it's just you're explicitly stating that, this is your, yeah, exactly, even with at AutoWire, I think you would specify the name, but you're explicitly stating that this is a resource that I'm using. If you can call out your service, your DAO or anything like that. It's just a different way of auto-wiring things. If one service needs another service, I could just auto-wire it rather than using at resource. It's just two different annotations using the same thing. I mean, doing the same thing in the end.
Right.
Yeah. I could have used at AutoWire there and it would be fine. Actually, let me show that to you.
Don't you need to name your variable the same as the name if you're going to use Add AutoWire?
At AutoWire, yep. And this way, that's absolutely right, thank you. And this way, your resources can be anything, and I can call my task service, right? I can call anything else. If I don't name it the same, it'll still work. But with at AutoWire, I think I do have to name it the same. So this gives me the flexibility of calling my local variable anything I want. And let's read on that and make sure it still works. Right. That one failed because I had that Azurta fail over there. I comment that out. Yeah, I tend to use at resource more because then I have flexibility on my client side to name whatever I want. And that way I never have to worry about, oh, what did I call that? How did I? Yeah, so I use that more often than the other one. Questions? Like I said, there's, this is just a tip of the iceberg. I just gave you a little dipping your toe into the Spring framework stuff. Just basic introduction to Spring and how it works. It handles transactionality amazingly. That is one thing because I have written code where I had to keep track of what transaction I'm in, and that is a mess. Probably remember from way back when, but so, Spring handles a whole bunch of things so much, it's basically, it takes care of all the plumbing and lets you focus on the important stuff, right? So it takes care of transactionality with batch, it takes care of the whole multi-threading. You can take your processor and multi-thread it if it could be run that way, no problem. It does all that stuff for you, and you don't have to write custom code. It's the code that we keep writing over and over and over again. So that's what it does.
Did it do interesting things with exceptions? Or just throws them all back out?
it throws them all back out. There's a lot of runtime exceptions and stuff like that. The one other fun thing it does is there's something known as interceptors. So you could have other things hooked into your normal flow of your code, and it would take care of something. For example, security is one of the things, right? So we don't want security just at the topmost level. We want it down to the database level, right? Even in a persistence, if you're not in the proper security authorized role, no matter how you got into that flow, if you don't have, it'll stop you right there. So you can implement security down to that, and then you can add interceptors. Some interceptors that I've used in the past. One is, at one of the clients that I had, we had to log basically who accessed what account, just that information. Who accessed what account, irrespective of whether it was batch, UI, or something else, right? So the way we implemented it was with an interceptor, so that way I didn't have to, so the interceptor took care of all that stuff. It figured out what that thread was doing, who was the owner of that thread, right? And it would log what, down to the account level. Whether it was a person or it was a batch, access this account, whether it was a read or a write. And we just wanted to keep a track of that log separately. I didn't want to add anything in my code, custom code, to handle that. And the best way to do that was write an interceptor and hook it in at the Spring level.
Because otherwise you're passing the user or the account all the way through all your different layers.
Exactly.
Or it doesn't really belong.
Exactly. So interceptors can do a whole bunch of things. The other thing that I implemented with interceptors was like there are 5 different things running in my mind right now, but I'll tell you one example. It was basically change tracking of down to the field level needed to be tracked somewhere else, not as part of my application.
Change tracking of, like, not database field.
Database fields, yeah. Database fields, change tracking of that down to the field level, somewhere else. So instead of writing all that extra code, all I did was an interceptor. And it kept track of, old value, new value, timestamp, and when it was changed and before it was changed. Same with logging.
Your applications are largely about money
Yes,
and who changed the money when.
exactly. And those logs, those are audit logs.
Yeah.
And we need that because, a lot of legal stuff, a lot of, and it's real money that we're talking about. So we don't want things like, fraud, whatever. If somebody
Right.
comes back to us and says, why is my payment incorrect? We have to track it down so we could tell exactly what happened between the last payment and this payment and why it was different. So interceptors, like I said, Spring, I've worked with that for, about 8 years now with Spring. It's come a long way. Other things, just go out there and just look at Spring Framework. I don't have internet access. It wouldn't let me in. So even though I'm connected, I can't.
So go to your logon, over in the login, you just have to click, just
Oh.
say accept.
Oh, right, okay. I didn't get that before. There we go. Let's see, Spring projects. So they do use GitHub quite a bit. you have a whole bunch of Spring security, Spring MongoDB, if you, NoSQL, Spring has put in a lot of support behind MongoDB. You know, there's so many different NoSQL databases. NoSQL, I can't call them databases, NoSQL frameworks, and, you know, there's Reddit, there's MongoDB, there's, NoSQL, there's, SQL for J, there's a whole ton of them. And Spring seems to put it in a lot of support for MongoDB. It makes things, if you've not tried that, try it. It's a totally different way of programming. It's a fundamental thing. Big data, there's your Hadoop. Spring Rule, it's for really rapid applications and things like that. Spring integration, when you need to hook different things up. Oh, let's see. There you go. And there's a whole list of those. There's really good tutorials. There's really good anything about you want to know about Spring is out there. Yeah. Now that. So here's my. Here's all the code for the Spring, but I need to verify that. Oops. I think I added it, but I didn't commit. Ah. Sorry, just did that today. So I will make sure that once I get back, I am gonna make. I'll also upload the presentation itself, so you have that as well. But that's where I put all my stuff in. That's my GitHub account. So.
All right, questions?
Can you explain, can you go back to the controller?
Yep.
I'm just kind of curious how the data is actually getting into the JSP.
Oh, yeah, sorry. So here's my controller, right? Here's this is how it's getting into my GSP.
Oh, model, okay.
My model is nothing but a map of string, which is my variable name, to my object, whatever that object is. So this is how I got my current time, right? And do I still have my GSP up there? Yep. So if you look at this, right? My to-do list, current time, and where's my application, right? So that is my current time. Test 2, right? It updated that, 7:57. So that's it's key value pairs basically.
So is Spring the context? Is that how the JSP knows that the model exists?
Because I defined that for this request mapping, list.do needs to call this home method, and that has that object, just that string, the map, the key value pair. That's my model. That's
and the
it.
JSP just kind of.
It creates that. So behind the scene, Spring is creating me a map of that string object map and handing it to me. And everything that I put in here, it's taking it back and handing it off to the JSP, the handler. And whatever I call this object, I'm just calling it model. I can call it blah, ABC, XYZ, foo.
Okay, so Spring is creating the model for you to populate, and then when you return the JSP, Spring takes the model that you've populated, the JSP, and applies the two.
Yep. So basically what it does is, old school is, it takes that HTTP request object, right? Because all this is HTTP request behind the scenes, right? Spring is only on this side. Attribute, so HTTP request, the only thing that you can put in is key value pairs, attribute, and your attribute name and attribute value. And so this is what it's doing. So it's taking my map that's my attribute name. And dumping the, whatever this value is into my request object. And this list is the name list. And this list is my variable list, which is just an array list. Array list of just strings, right? And so in here, this is my, my JSP. This is where I'm iterating. Oh, I did use JSTL for a little bit. Okay, so that's my for each loop. For each, this is my variable item, and that's my list, which is this guy, right? This maps to this. I could call, I could have called it, you know, task list or tasks. Whatever this thing is this. And then it's iterating through that and displaying them. So here's my form, here's my delete form. My hidden item is that. And here's my delete button.
So right now, the project that I'm on, we're actually doing attribute dot put.
Dot put, right? Yeah, exactly.
So we're
Yep, yep,
pushing
yep.
that stuff directly to the JSP.
Yep,
And, well, and
Yeah.
not using Spring for that, so.
exactly. And here's the, you know, fun thing, this thing, there is no request object, there is no response object at all. The other fun thing that I know we are out of time, wanted to show is, if you want one method at the end to call some other URL, this is what I do. I'd redirect it. Right? My home, I just want to redirect it to my list.do. And it's restarting over there. So now if I go back in here and say, you know, welcome.do, earlier it would take me to that.
You got clear cache on Firefox.
Oh, probably too, and I'll probably restart that. There we go. So even though when I said welcome.do, it'll automatically redirect me to that page. So that's how you do redirects, and that's the code for that. Yeah, so in here, my controller has nothing to do with HTTP requests or responses or anything like that. All I'm dealing is with objects, right? My model is just my map, my key value pairs, and what my request mapping maps to each one of these methods. So that way it takes care of all the ugly stuff that we have to keep writing over and over again, and lets us concentrate on what really is important. That's what it does best, and the plumbing, right? So it takes care of the transactions, it takes care of all that fun stuff. Right?
Okay, thank you.
Thank you so much. So I will put that out there as soon as I get back home.